Hello, and welcome to our presentation of our paper on Black Magic in Deep Learning, how human skill impacts network training. This is work done with Kanav, Zichi, and Marco. My name is Jan van Gemert, and I'll be presenting this paper. Now, we now are doing deep learning for everything. So in computer vision, in speech, in bioinformatics, everywhere, we're doing deep learning because, well, we don't have to handcraft our features anymore. Instead of handcrafting the features, now what we're doing, we're handcrafting our architectures. So we're now developing an architectures and we're also optimizing them. And optimizing them means there's a huge number of hyperparameters. So here are some examples, such as learning rate, the batch size, do you use momentum, what kind of optimizer do you use, how many epochs, what's the learning rate decay, how many layers, what's initialization, the activation function, do you use dropout and how much, and rate decay parameters. All these things have to be set. And these parameters, they are essential for making fair comparisons and to doing reproductions of existing results. So there's work, see our paper for the references, this famous work by Google where they evaluated all the guns. And then they found actually, well, if you tune the hyperparameters of these guns correctly, there's actually not so much difference between them. And a similar observation was made in natural language processing, that these hyperparameter values, they are really essential. Now, in practice, the tuning of these parameters is done by your data scientist, by your human expert. So there's much work now in AutoML, and in neural architecture search is trying to automate this. But in practice, this is often still done by a human expert. And in our paper, we asked the question, how large is this role of the human expert on the final performance of your deep network model? Now, we have the following 4 contributions. So we have a user study. We have a controlled hyperparameter tuning setup. So we ask users in a completely controlled setup, everything is the same for all the participants. We ask them to tune the hyperparameters of a fixed deep network. We investigate if there's correlations between the experience of these users with the accuracy that they then obtain and how fast they obtain the accuracy. We also look a bit into search strategies, and we end with some recommendations for reproducibility and model comparisons. Now, the experimental setup. So what did we do? So we have a fixed deep learning setup. So the task, well, it shouldn't be ImageNet, because then you train for a week. So what we did, we took ImageNet, which is a subset of ImageNet, which is 10 classes with 13,000 training samples, 500 validation, and 500 tests. This means you can, well, within a reasonable amount of time, you can still train a model and evaluate some hyperparameters. So this model, it also shouldn't be too big of a model, because then again, that takes lots of time to train. So we chose SqueezeNet, which gives reasonable performance in a reasonable amount of time. And then we have some hyperparameters. So we have 15 hyperparameters that the users then can manipulate. 4 of them are mandatory and 11 are optional. I'll show some examples in a bit. In addition to the deep learning setup, there's also this participants setup. So we need to provide some user interface for a participant to interact with the model. So we designed a web interface with an option for early stopping. So if a user says, okay, this parameter is not really working for me, I want to stop and I want to try a different value. We try to match a realistic scenario as close as possible. And then the task was to, in maximum of 2 hours, find the best parameters and submit your final parameters for evaluation. And those parameters then we take and we train a model. So we take, the user gives us these, so the participants give us their final hyperparameters. We take them, we train offline a new model with those parameters on the train and the validation set, and we evaluate it on the test set. And we do this 10 times. And to prevent from any other randomness, we make everything the same for every participant. We use the same GPU, we use the same seed for random initialization, we use the same samples. Everything is the same for each participant. The The only thing that varies is the number of the hyperparameter settings. And here are some examples. So here on the left, you see the hyperparameters that are mandatory. So the number of epochs, the batch size, the loss function, the optimizer, and the other ones which are optional. And then in the graph on the right is again, it's a histogram of the accuracy on the validation set if you try some random settings of these hyperparameters. So this histogram says that, look, there's quite some variation. If you don't set these values correctly, well, you don't get a very good performance. So there's quite some variance. So there's quite, well, if you do this well, you can, at least it should be possible to get good performance. And if you don't do this very well, then your performance will not be so good. Now, the results. So what you see on the left, that's the distribution of the participants based on how number of months of deep learning experience. So you see most of them don't have so much experience, and we do have some that have more experience. And then we divide these participants into 3 groups, into a novice group, a medium group, and an expert group. And then in the plot in the middle, then you see the accuracy of these groups. So the novice, you can see there's huge variance. So this is a box plot. So the size of the box gives you the variance, and the red line gives the median, and this green triangle, that's the mean. So novices have huge variance, and also their median and mean accuracy isn't very high. If you go to the medium experts, they do a lot better. And the experts, they even do much better. So there's quite a statistical, we did statistical significance testing, and we did find significant results between these 3 groups. But even within these groups, there's still quite variance. So even for experts, there's quite some variance in the hyperparameter settings and the results that they get. Now the plot all the way on the right, that evaluates how fast participants obtain certain accuracy. Here again is the 3 groups. There's the novice, the medium, and the expert. And what you can see is that the expert is the top line. So they take less time to get a better accuracy. So they reach a higher accuracy faster. If you want to see some more analysis, we also looked at comments, and you can look at the statistical tests we did. Yeah, please have a look at our paper. Now, what does this now mean? It means that human skill does impact the final accuracy. So it means that there's a human there in the deep network training. That human has quite an effect. If you have a better human there, you may get some of your percentage extra just by being very skilled at hyperparameter tuning. We also show that more experience correlates with optimization skill. So if you have more experience, you can do it better, you can do it faster. So it's all good. It's good to have this experience, and it's also good to know that this experience plays a big role. Then we make some recommendations. So we think that all papers should share their hyperparameter settings. Most papers do this, but not all of them. Make your code available with the hyperparameters so that it's reproducible. If you're comparing to baselines, please also optimize their hyperparameters, because it may be very important to set them. If you reach superior performance, it's very good, but it could be that just a small improvement in your bold numbers stem from the fact that your human expert is just better at hyperparameter tuning. So as a field, we think we should make these bold numbers less important. For more results and more discussion, please look at our paper, and I wish you a good day.